Let's see. Sidebar. So folks, this is the HTTP working group. If you're not here for the HTTP working group, please leave in an orderly fashion. I think it's more pressure on some people, don't worry. I'll throw the blue sheets. Oh, thank you. We're just about to send the blue sheets around. Thank you, Barry. You anticipate our needs as always. Excuse me. So some preliminaries. This is the Note Well statement. This is the intellectual property terms which we participate in the IETF under, which is very important. It's one of the primary functions of a standards body is to give you well-known terms for intellectual property and antitrust. So please, if you're not familiar with this, you can use your favorite search engine for IETF Note Well, but you do need to be aware of this. It affects your contributions here. Another bit of policy which unfortunately doesn't get quite as much attention, we strive to have a harassment-free environment here. There is policy on this, which is in the referenced RFCs, and we have an ombuds team. So if you feel you're being harassed or you come across a situation that causes you concern, you can contact these kind people at the bottom, either personally, that's why we have their pictures, or using the email address, or you can talk to the chairs if you'd like. But we take that very seriously as well. So, the blue sheets are going around. Please sign them. We need a scribe for this session. Do we have any volunteers?
Come on.
Murray, I saw you out. Oh, Yof? Thank you. You're a kind gentleman. Can you handle the Jabber relay, or should we get someone from the crowd?
I got Jabber.
You got the Jabber? Okay, you've got the Jabber. Our agenda. We have 2 sessions. In this first session, we're going to go over our active drafts, and then we are going to go over a few bits of proposed work that has been discussed. If we have time at the end, we have a presentation on secondary certificates. Any discussion of this session's agenda? Just to give you a preview, the next session is exclusively about Quick and HTTP. So we can hold all those discussions till then. Okay? All right. So let's go ahead and start. Our first discussion is of RFC 6265-BIS, which is the cookie spec, and we have the editor of that spec here. Mike.
Hello, I'm Mike West, and I have been working on the RFC 6265-BIS draft. I have a brief update for you all today. Basically boils down to 2 things. Thing 1, I am slow, and thing 2, I have questions. Before we get to details of the draft, I want to talk a little bit about the code that we have running out in the wild based on some of the drafts that are going into this revision of the cookie draft. After a long ramp up to an increasing number of users in stable, Chrome rolled out the restrictions on the secure attribute in, I think, Chrome 56 at the end of January of this year. That led to a short-lived surge of bug reports from people who were now being affected by this that weren't affected before. That has basically trailed off at this point, and I think it's something that we're going to keep in place. Firefox shipped the same restrictions in Firefox 52 in March of this year. As far as I know, they're also planning on keeping this restriction in place. I haven't heard anything from either Apple or Microsoft about their implementations, but this is certainly something that is affecting large numbers of users and servers today, and I think it's something that we're actually going to be able to ship and keep in place. The second thing are cookie prefixes. So there are 2 prefixes defined in the doc, _secure and _host. Based on the, Chrome shipped these last year, Firefox shipped these last year as well. Based on the metrics that we have in Chrome, the secure prefix sees practically no usage. I think there was something like 16,000 set cookie headers that we saw over the last month, whereas The host prefix sees also not a lot of usage, but something like 0.005% of the set cookie headers that we see carry a host prefix. And I know of at least 2 session fixation attacks inside of Google that this is actively prevented. So it is pretty useful. It's something that I'm happy that we're shipping. Again, I haven't heard anything from either Apple or Microsoft, but Firefox and Chrome are both shipping implementations today. Same site cookies shipped in Chrome 51 last year. Mozilla folks were also working on an implementation. It looks like that implementation is stalled, but it still seems like there's interest in that implementation from Mozilla. Again, I haven't heard from either Apple or Microsoft, but we're hopeful that this kind of thing seems to have a lot of popularity with developers. We see something like 0.01% of set cookie headers have already adopted this, which is actually larger than I would have expected, given that it's only implemented in one browser and that it provides enough protection that developers seem interested in defending themselves against CSRF using this attribute. So with those implementations in mind, let's move to the draft that is cleverly up on the screen in front of you right now. Long story short, I'm just slow. I missed the draft deadline for this IETF. I have a draft on my local computer that has all 3 of these specifications stuffed into it that I'll upload as soon as those restrictions are lifted so that you can actually take a look at it and give some feedback on it. One area in which comments would be particularly helpful regards the layering between the cookie specification and the fetch and HTML specifications that are currently being worked on in the WhatWG standards body. In particular, same site needs a couple of, has more understanding of HTML and of fetch than I think it probably should have for this document. But it's not entirely clear to me what documents the IETF actually wants to reference and to what extent the IETF document can pull in concepts, specifically from fetch and from HTML, that have a lot to do with web browsers, but don't have a lot to do with clients like curl. So figuring out exactly what that layering should look like and providing a clean entry point to those other specifications is something that I'd love to get y'all's feedback on. I can imagine pulling things out of the same site portion of the spec and putting them into HTML, putting them into fetch, and then providing a set mechanism of some sort that would set the header based upon a set of attributes that are passed in. I can also imagine using the request concept from fetch directly in the cookie specification in order to read that kind of data ourselves. But getting feedback from you all about what that layering should look like would be super helpful. The last thing I would note is that Martin Thompson put together a draft last year that was adopted by the group. I forget what the name of it was, Eat Cookies or Eat Non-Secure Cookies or Nom Nom. It's not entirely clear. But the basic idea is that we should treat cookies that are delivered over HTTP in a different way than we treat cookies that are delivered over HTTPS. Given the amount of adoption of HTTPS over the last year and a half, I think it's probably time to revisit that specification more actively and start exploring what that space might look like. This goes to the point of defending against pervasive monitoring and also encouraging advertisers and others who embed third-party content to migrate to TLS in order to allow the first party to migrate to TLS as well. So I think that's an interesting spec. I think it's something that we should look at. I don't think Chrome would implement it as is, but I do think that there are some subtle changes and minor directional changes that we can make to it that would make it pretty appealing, both for Chrome and hopefully for other vendors as well.
Yeah. So Martin Thompson, the point of that draft is really to establish a set of principles by which you might set policy. And so the policy that Chrome implements, if they start going down this path, will be necessarily a subset of the things that are described in the document. And over time, we might see that change. And that's one of the risks that we have with writing documents like this, is that this touches on policy space. And we need to allow for the fact that the environment changes over time. And as Mike points out, it has changed to the point where this has become interesting. In the future, it may change to the point that we can actually make a more definitive statement about it. But for this intervening time, we have to think about allowing user agents the ability to set policies and providing some sort of guidelines and a framework for doing that. And I think that's the intent of the draft. And I'm very happy to talk about what those policies might look like or what guidance we might provide regarding that.
Yeah, so
Mark looks puzzled.
I'm just curious if, Mike, you wanted something more definitive, or if you agree with that statement.
I do agree with that statement. I think the direction of the document that you wrote is the right one. And I think that what we need to do collectively is figure out ways to get to that without having sincere negative side effects on the ecosystem. And I think we can do that. That's all I got. So if you have any questions or feedback about cookies, great. I would be happy to have them.
So just from my standpoint, and I don't know if I'm wearing a hat or not, personally, I'm willing to try referencing a what working group document. I think it is going to require some talking to people and thinking, and we'll see how it goes, but I'm willing to try.
That makes sense to me. I can basically see two paths. One is that we reference that document and we use its concepts directly. The other is that we provide an entry point to that document with a lot of Booleans and parameters that get passed in and allow the embedder of cookies, whether it be a user agent or whether it be curl or whether it be something else, decide what the meaning of those terms is. Mm-hmm. I'm kind of unhappy about doing that because I think this document should define the terms in a way that is interoperable, but putting those definitions into HTML or into Fetch is also viable.
Okay.
Cool. Thanks, folks.
All right. Next up is Expect CT, I believe. So Emily? Oh, full screen. My old friend. There we go.
Okay, hello. I'm going to give a quick update on Expect CT. The main thing is the next slide, which is that we're getting ready to ship an implementation in Chrome. This will be branching very soon. It's going out with Chrome 61, which goes to stable in September. If you are a site operator who's interested in using Expect CT, now would be a good time to start thinking about that. It would be great to have some sites using it as Chrome goes into beta so that we can figure out if there are problems, figure out how it's working, etc. before it hits stable. Okay, so I wanted to give a quick update on some of the open issues, and well, hopefully neither of these are open still, but we'll see. So one of them is fairly minor. I updated the reporting format to handle both SCTs in both 6962 and 6962-BIS format. So it specifies how clients supporting either of these versions of CT can report their SCTs. The next open issue is CORS. This is not, we discussed this on the list a little bit. This isn't really that relevant to the IETF, except that it affects implementers of this spec. So I wanted to just talk about it a little bit.
Your slides are right in front of you, Emily. Right there.
Okay, so the issue here is that Expect CT reports, like many other types of reporting that browsers implement, arguably fall under CORS restrictions that prevent web content from triggering arbitrary requests to servers that don't expect those requests. There are various hacks unsatisfying solutions that we discussed on the list. One of them was to just bite the bullet and send pre-flights for Expect CT reports. This is not a hack on the face of it, but it turns into a little bit of a hack because of implementation concerns. We can take reports and stuff them into a request that does not need to be pre-flighted according to CORS, or we can just knowingly violate CORS. Those are our options right now. What I have ended up doing in the draft right now is just leaving it up to the client to decide what makes sense. Obviously, it doesn't make sense for a non-browser client to send pre-flights. And browsers can also reasonably disagree on whether they think that these requests are subject to preflights. In Chrome, what we're doing is we are sending preflights right now, but my plan is to go take this up with the fetch spec and see if we can carve out some kind of exception that makes sense for reporting requests. Because the fact is that there are a number of reporting requests right now and other kind of browser-generated requests that violate CORS and will continue to do so for the foreseeable future. So that is where I think things have settled. I'm curious to hear whether people agree with that. Next slide. But other than that, if those issues are resolved, I'd like to see if we're ready for working group last call, because I don't have any other open issues or plans to make changes right now.
Hi, Nick Sullivan, Cloudflare. Just a quick question about expect-CT. Can the report URL be on the same host name as the event that triggered it? This would sort of avoid your CORS issue, and it would be easy for something like Cloudflare to deploy widely if that was possible.
I don't think the draft says anything about it right now, but I think the Chrome implementation does not allow them to be on the same host name, same as for pinning, because of looping possibilities.
Yeah. So Martin Thompson, I don't know that we ever really got to the end of this one. I think there was a lot of talking, but we never really came to any conclusion on the thing. And I would like to reach some sort of conclusion. Can you explain to me why it's not possible to put the origin of the response that contained the expect-CT header in the origin for the pre-flight?
It's possible, but incorrect. I mean, that's not what the origin header is. The origin header is the context that initiated the request. So
yeah. So who generated? In this case, it's the entity that generated the URI.
Right.
The thing that controls the URI that goes in that request is really what matters in this context.
I don't think it is.
They're the attacker, if anyone's the attacker.
No, I mean, if evil.com has a sub-resource, includes a sub-resource from victim.com, it's victim.com that has to opt into receiving that request from evil.com. So it's the evil.com origin that needs to go in the origin header.
Okay, maybe this is not the time to talk that through. I don't know if that's correct. Because the expect-CT header comes from the victim, yes?
Yes, but evil.com is initiating the request.
Yeah, so who initiates the request in this context doesn't actually matter, because victim.com is the only one who has any control over their expect-CT.
Oh, well, the other issue is that it doesn't, you're saying if victim.com chooses to serve expect-CT, then they are opting into receiving reports. But the report URI can be arbitrary, so
that's why you need the origin field. I mean, as Nick suggested, if you weren't going cross-origin for this, if victim.com didn't want to send their reports to ctreporting.com, then we designed the system such that they were the only ones that could receive it. That would not be a cross-origin request in that sense, because the victim.com is receiving reports at victim.com, and it's the one setting the thing, and it's not a cross-origin request. I think your modeling of this as the thing that initiates the request that then, the HTTP request that then causes the certificate validation to occur as being the triggering origin is incorrect. I think you need to perceive this as the thing that sets the policy and sets the reporting URI as the one that actually initiated the request.
Yeah.
And then it's different. And I think we might have been talking past each other when we were talking on the list. You're saying this is really impossible because we have this context, and I didn't understand that that's what you were thinking about.
I see.
Because
Yeah.
to me, it was obvious that the person making the request is the one that sets the expect CT.
Okay,
header.
yeah, I think I need to think about that a little bit more, but I think I see what you're saying. And,
Right.
Yeah.
And would that make, okay, you think about that some more and see and decide whether or not you think that the carve out for cause is still necessary, because the carve out for cause is problematic.
I suspect I will end up thinking that the carve out for cores is still necessary for other reasons, but
Sure.
we can talk about that
and
some other
This
place.
may be the wrong place to be having that discussion ultimately, being the fetch spec as the venue
Yeah.
where that sort of thing gets decided. But we can offer some advice. I don't know if we can get Anna involved in this conversation any more than we have, but that's really what it comes down to.
Yeah, and by the way, after thinking about it a little bit more, I don't actually think the null origin is that big of a hack. Like, it's fine per specs as far as I can tell, and it is safe as far as I can tell, in the sense that it does require the server to opt in, and
Yeah.
unless the report collection server is an internet server, I think it's fine. But I see what you're saying.
Yeah. So the alternative here that still ends up with two requests is for the person setting the expect CT to set up a resource for reporting on their own site, and you never have it's never a cross origin request from this perspective, and then you don't have a pre-flight. If they do want to use an external service, they can use one of our wonderful redirects, and we'll post across to the external service. That's possible, right? So there's a number of different ways that this particular cat can be skinned, and I think we should talk those through.
So it seems like the conclusion is to leave that issue open for a little bit more time. And
Yeah, though, I mean, another way one could read that is that, I mean, the draft doesn't really say anything in particular right now. It says that if the client is supposed to be sending cores, the client should send cores.
Right.
So I'm not sure that any of these.
Yeah, so Martin Thompson, I would like to see at least a plan for a solution, whether it be here or in some other document. If it is entirely appropriate for this document to say basically nothing about cores, then that's fine. But I don't want to ship this thing and then find out that the conclusion of the discussion on the fetch spec is that this document had to do something. We don't need to ship it in a screaming hurry, do we?
Do we have a specific issue about this open on the fetch spec?
Yep, it's 356. It's open.
No,
Okay.
Oh, fetch spec?
In the fetch spec, yeah.
I think there was one open. Did you open one?
I don't think there's one specific to expect CT. There's one about OCSP, which is a whole other fun discussion.
Well, yeah.
Right. Because it seems like Anna and Sleevey and a few other folks need to be consulted. So,
I'd say so. Yeah, let's talk to those guys, and then
all right.
This is important to them, so it shouldn't be difficult to get their time. So
Hopefully.
Yeah.
Yeah. All right. Any other questions or comments for Emily? All right. Thank you.
All right, thank you.
so is Paul Henning with us? Silence. All right. So the next item on our agenda is about the header comment structure draft. Mark is going to do his best PHK imitation and give us an update.
That's quite a bar. I don't think we have a lot to talk about here. There hasn't been a lot of activity on this spec. What there has been is some confusion about the scope of the specification. In that I think people think that this spec is for different things. And my understanding from the discussion that led us into adopting this spec, and indeed the discussion about JFE, which was its predecessor, was that we were most interested in something that would improve the experience for people authoring new headers so that there were less pitfalls facing them and they had something they could rely upon, and also to make headers more reliable to parse. There are some secondary goals in terms of making headers more efficient or allowing alternative encodings of headers, but those were not our primary goals in doing this work. And so I guess from my perspective, I'm interested in what people think about if I've got those goals right, and if so, whether we're still on track for meeting those. Does anybody have any strong opinions or even weak opinions about that? Julian, I see you out there.
Hi, Mike West. As someone who is minting headers, I liked JSON a lot more. I think JSON, from a web developer perspective, has tooling everywhere in every language. It's very easy to use, is well understood by developers who are going to be setting headers and reading headers. And that seems to me to be a strong argument in favor of something that reuses things that developers know about today.
Thank you.
Julian says on Jabber, we're not making progress. That's the main issue. And I'm willing to get the JSON spec out as a non-working group spec.
Right. My response to that is I would ask for a little bit of Julian's patience in that if we can come to a solution as a working group, it would be nice to have one way to do this instead of two. But let's maybe give it a little more time.
Michael from Meet Echo, you're on the air.
Well, let's pressing the button.
Okay. So I would agree with the goals as you stated them. I would say that from discussion with our dev team, we really don't want to be including a JSON parser that low in the stack. If we have to, we will, but I'd prefer we not go that route, and I like this draft a lot better for that direction. But again, making progress is the issue here.
So, Mike, I guess, again, speaking personally, I look at this draft and I have a hard time getting from it to, I think, where we need to be. It doesn't talk about parsing, error handling, the author experience, any of that. And it does seem complex. Personally, I'm tempted to try and write a draft to offer another approach. Do you think that this draft that we have now is 50% of the way there, 80%? Is it salvageable?
I suspect that it is salvageable. I agree with you that there are probably some pieces missing, and it would be interesting to see a draft or a pull request that tries to fill those in.
Okay. I might talk to Paul Henning, and
I think we need to huddle. Yeah.
Mike West again. One thing I would note about the JSON parser is that I understand that putting a JSON parser into the net stack seems strange and difficult. One nice thing about JSON is that because we have implementations, and because those implementations are exposed to the web, they've been very well fuzzed, and we have a very good understanding of the security properties associated with them. Given that, I don't have that much trepidation about using the existing JSON parsers in places where they aren't currently used, because again, I think they've been very well fuzzed.
I'd love to hear from Daniel Stenberg, but I don't think he's about, is he?
I'm opposed to using JSON since even in the most popular JSON parsers, we found incompatibilities that result in different interpretations. And since it's about headers and misinterpretations or disagreement between how for example, a floating number would be interpreted might result in a security issue. So I'm strictly opposed to using JSON, and I favor using this HTTP header common structure as a basis.
So Martin Thompson, I sort of caution against getting too much into what we'd prefer to do A or B. Right. I think we've actually heard a lot of those comments before about Julian's draft and about this draft. I think part of the problem with the current draft is that it originally came from a place where it was being a little more aspirational in its goals. And a lot of that legacy remains in the document. And
yes.
Maybe it can be salvaged, but I would like to see those goals articulated first, and that would be worthy of.
Yeah, I think that's our conclusion as well.
Yeah.
Right. And I think one thing we can do, we started the discussion on the list about these goals. We probably need to finish that and get consensus on them. I don't know that we're in a place to get that consensus right here and now, because we need to articulate them a bit better. But let's go ahead and do that and then see where we sit, perhaps.
Right.
Anything else in this one?
Not for me.
Okay.
Kazuo, Cache Digest.
Yes.
Screen's right.
Let me just find the presentation.
Hi, so let me explain about the changes that has been made to the Cache Digest draft. Next, please. So there has been 3 changes, and well, first let's talk about the last one. And the intended status has been changed to experimental, as we discussed in Chicago, since browsers are unlikely to have support for Cache Digest in the near future. And instead, we've added definition for the Cache Digest header, and considering of going to experimental. So next, please. So the Cache Digest header is a emulation of the Cache Digest HTTP to frame, which is not as optimal as using a frame, but it kind of works. And it's already being implemented in Apache, H2O, and also there's a node module called Cache Digest Immutable. And there are some small-scale deployments that already have this being activated. And the header looks like this, and it's basically a base64 form of the digest value and some flags. So it's pretty one-to-one matching between the frame definition and the header definition. So next, please. And we also have a new feature that is actually an HTTP2 setting that allows the server to tell the client whether it supports Cache Digest. And the issue we thought that it existed, but since Cache Digest needs to be sent in 0 RTT, there was no way to let the server to notify the client whether it wants to, it can accept Cache Digest or not. However, we've noticed that since TLS 1.3 full handshake lets the server speak first using the 0.5 RTT data, we can notify from the server to the client that if it wants to see a Cache Digest before client has the chance to send any data. So this takes advantage of the approach. And on the other hand, 0.5 RTT is only available in a full handshake. So for the 0 RTT resumption, the client needs to remember if the server supports Cache Digest and have that information associated to its TLS session cache. Next, please. And well, while that might sound complicated, my understanding that TLS stacks would have that kind of will support that kind of association. I mean, associating external data to session cache, since that is also a requirement in Quake. So we have this API, and we hope that browsers, once they decide to support Cache Digest, can use this thing. So I think this was my last slide.
Yes.
Yeah. So these are all the changes we've made since Chicago, and so the question is what the next step is. Maybe we could go to last call, or
Right, and so that's the I guess the question is that we've been letting this draft hang out around for a little while to see if a browser would implement it. And we don't seem to have anyone prioritizing it in a native browser implementation, although as Kazuo mentioned, we do have some header implementations. And so if we don't get any information about that, I think it makes sense to take it to last call and go as experimental. TKG.
Hi, this is TKG. I apologize that I have not read the draft. Does the Are you expecting for the client to remember this for the duration of the resumption ticket, of the TLS resumption ticket? Or,
Yes.
So that's the explicit duration that you want that to be cached?
You mean, the accept cache digest header will be remembered for the duration of the session ticket.
Of the session ticket?
Yeah.
Okay.
On the other hand, the cache state, is more stable, or I mean the persistent thing.
Right, but this particular header is synced in it's retained specifically alongside the resumption state.
Yes.
Okay.
So does anyone have any comment about going ahead to working group last call with this? Does any browser vendor want to shout, no, I'm going to implement that? Right. We did have some interest, but we didn't have a commitment. So, Mike.
I wish I could be doing the shouting that I'm going to implement this, but I think we're still in the same state of interested in it, but don't have any immediate plans for it. We want to see how it goes. Could you remind me, though, what is the size, particularly when you base 64 it? What kind of size do you need for acceptable false positive rates?
Sorry, could you?
What size do you typically see with the header version when you base 64 it to represent a reasonable cache with a reasonable false positive rate?
Yes, my understanding that we only have very small size deployments at the moment, so the number is quite small, like 100 bytes. My understanding that.
100 bytes, Mike.
Yeah.
But for the very limited deployments we have now.
Yes.
When you use the header, I assume something like the service worker cache, and so you're choosing what you store in it rather than doing a full HTTP cache.
Right. So for a large scale site, and our anticipation was that a cache digest frame would typically be 1 kilobyte. 1 kilobyte.
That rings a bell. I think that's what I came up with as well.
Yeah, and it kind of bloats due to base 64, and it will have some impact on the HBAC compression rate. However, the size is likely might be less than half of the HBAC state. So hopefully we can live with that.
So Martin Thompson, you said less than half the HPAC state. How big are you actually making these things? I didn't think it was that. I didn't think they were that big.
Yeah.
And people are advertising pretty large HPAC tables now, after realizing that the default was fairly small.
Yeah.
So
yeah.
I think part of the problem here is that this is an experiment backed up behind what is effectively another experiment. And the success of server push on the whole doesn't hinge on this, but it is still in question.
I think some people would disagree with that. I think some people see this as necessary to make server push successful. And I know that that's a contentious topic, but some people have stated that.
Sure, but a lot of the problem, this solves some of the problem with server push, but not all of the problems that we've discussed at some length in other venues. But to the extent that it fixes the problem, it is also equally encumbered by the other problems that are attached to server push. And until we understand more, we can't really say whether or not this is the right solution. And that's why I think we should publish it as experimental and just it's been sitting here. It hasn't changed in some ridiculously long time now. There are implementations out there. Let's see how the experiment runs.
Right.
And explicitly say this is an experiment to determine whether or not we can fix server push.
The one thing we were kind of waiting for was the whole discussion of golden compressed sets versus cuckoo filters, but that seems to have, without more data, we can't really make a decision there otherwise. So we decided just to stick with how it is.
So in Jabberland, Stefan notes that size depends on the probability you want to achieve, which Mike agrees with.
Hi there, Brad Lassie, Google Chrome. Just to answer the question of what our status is, we're interested in this, but it's not prioritized. The biggest problem we see is it's quite hard to implement within our current cache implementation. So, and we're not sure that this is the right solution to server pushes problems. So if this doesn't have a high probability of being required, we don't want to put the investment in to rewrite our whole cache to support it. If that makes sense.
Jana Iyengar, Google. Just came up to Jana Iyengar, Google. I just came up here to, can you hear me now?
Yes.
Yes. To say that I agree with Martin in that this seems like an experimental proposal. Unless there's any other way to do this, that's the way I would publish it as experimental.
Right. Thank you. And I think the worst case is that if a browser gets interested but discovers that this isn't the right approach, we burn a frame type and have cache digest 2 or whatever it is. But it's still worth publishing, I think.
It's a bit we'll never have again, Mark.
What about the bits? We will think about the bits, yes.
Thank you, Kazuha.
Thank you,
Thank you.
Kazuha.
So, Mark, I have a friendly, I have a request for an agenda bash. Can we at least move the origin frame a little later? We have someone in another room doing a presentation who would like to be here for this.
Certainly.
So, just a request.
That puts us at random access and live content.
We'll find out if Darshak is paying attention or he thought he had another 10 minutes.
And you checked in a PowerPoint presentation.
I checked in what I was sent.
Bad Patrick. Hold on, let's see if I can make this work.
It's actually really quick. We will not even need the presentation. I can go without.
No, okay. We're getting there. I can't guarantee the fonts will be exactly the same.
That's all right. Yeah. Okay. So I'm here to just give a quick update on the random access live draft. Next slide. So I think at the last working group, we actually had requested comments or feedback from the working group. We haven't received any specific concerns or comments. I'm assuming people have probably read it and no problems at all, or people haven't read it. And the other feedback that we had received was to actually just try out, the protocol or the idea, and make sure that it actually works with caches and intermediaries and doesn't have any problems with that. So next slide. On that note, so we are actually just working on kind of building a test framework. So we have our client and server sort of ready. We were hoping to finish this before this IETF, but we are a little bit behind. So we'll still finish this and send out our observations or results. Our hope is that the answer is there are no issues with caches and intermediaries, but we want to verify that hypothesis. And that's pretty much it. Next slide. So any questions? And I guess the question to the working group would be, is it a good time to issue a last call, keeping it open pending our results, or should we wait?
Let's ask the question of who's read the draft.
Raise your hand if you've read the draft. Live access and random access and live content. Okay.
6, 8, 10, 8?
Plus us, I hope.
Yes.
I would observe that we can do a last call fairly quickly, and so if you were to bring the data either on the list in the next month or two or in Singapore, we could issue a last call and have a 2-week period and then done. We do a soft last call if you like.
I mean, we are sort of right now asking for any concerns, which is a very similar question to a last call question,
Indeed,
right?
Yeah.
So I would say if you've got an active experiment, I'd prefer to see it finish, and then we can do just a 2-week call.
Yeah, we're hoping to do it before Singapore, so for sure.
Okay.
Sounds good.
Great.
Thank you.
Look forward to hearing about it.
HTTP replays? Just keep going on?
We can do that, sure. So replays. This is Martin.
Oh, wow, that's bright. All right. So one of the things we've been doing in TLS is this 0RTT theme that has everyone in a flap. And one of the things that document requires of us is to explain how how it is that you use your protocol with zero RTT before you actually start using it. Full disclosure, we may have deployed this already without any of the measures that are in this document, but such is the nature of the pre-release channels that it's been deployed on that I think we probably claim that, you know, there's an experiment out there right now. It just happens to be sort of rather large. Next slide, please. So the primary risk here is that zero RTT lets the client make requests, but the TLS handshake isn't done. As a consequence, there's no fresh state from the server mixed into this, and the requests can effectively be replayed. Now, TLS mandates that you do some anti-replay stuff, and they're imperfect. What can I say? Next. This is what the draft does and says. It says that the TLS connection is modeled as a single stream. There was a lot of debate about this in TLS as to whether you would have separate compartments for the early data and the other stuff, and you would somehow have some sort of clear delineation between the two of them. Practically speaking, that doesn't work for HTTP. I'm not sure that it works for many TCP-based protocols. It may work for things that use the datagram protocols, but we're not done with DTLS 1.3 just yet. And then the document contains advice, some basic guidance on what to send in zero RTT, and on the receiving end, what you might want to do with it and how you would deal with it on that end. And then there was some discussion that we had in a workshop about intermediaries, and we realized that it would be really nice if we had a couple of mechanisms for intermediaries, and we defined some of those. Next, please. So, the advice for clients, we recommend safe methods in the document. There's some sort of hand-waving with shoulds and mays and whatnot that allows for other things. In the browser context, different policies will prevail depending on your attitude toward these things. The other thing is that we actually mandate an automatic retry of the request if the zero RTT is rejected, and we talk about the fact that you might decide not to send a request anyway. But in the general case, if you made the request in zero RTT and zero RTT is rejected, then you will make the request again. That would be the default operation unless someone has used one of the new methods that we're providing to cancel the request in the meantime. I think that's probably the only out that we have on that one. It's important to recognize this enables an attack, and the draft explains that. But it's a one-time only. It's a visible thing, and we are being very careful to distinguish between the effects of retries from the effects of replays. And the distinction here is that a retry is something that the client does with full knowledge of what's going on. A replay is something an attacker does with the packets on the network, and this is language that's being used in TLS as well. Next. Advice to the servers here. First thing is, please consider whether you want to enable zero RTT at all. And this is something that TLS does not necessarily enable by default. You have to turn it on. We have some advice on that one. And then it says, whatever you do before the handshake completes, that's the risky stuff. And the assertion in the draft and the model that we have sort of adopted for this, not formally verified, disclaimer, is that if servers always defer processing of a given request until after the handshake completes, then they will only ever see that request once. That's an assertion. Like I said, not sure about that. And so the recommendation following on from that is that if you're not sure whether something is safe, wait. And so this has some performance downsides, but the consequence of this is that when you get these messages, you have some certainty. And the performance downsides aren't, it doesn't completely eliminate the performance gains from zero RTT. The opportunity cost of having this slot is not completely wasted. So you you can send all the bytes, and then the bytes are ready on the server, ready for processing. And you can even do some basic parsing, as long as that parsing is sort of content agnostic, side effect free, and all the sorts of things we talk about. So there are still some benefits to having the data arrive without actually doing anything about it. And we talk about that as well. Next, please. Intermediaries with the interesting discussion. So an intermediary really can't decide what's safe just based on the knowledge they have typically. So what we recommend here is that an intermediary marks the requests that arrive before the handshake completes with a new header field. And that header field signals to upstream servers that the request may or may not be safe as a result of something that happened further downstream on the path. And that origin server can reject those requests if it thinks that they're unsafe. Or it can defer processing on them or do whatever other things it might want to do. Deferring processing at the origin is difficult because it doesn't know when the handshake completes and doesn't know whether that signal doesn't arrive. So the implication here is that the header field is only really used by intermediaries. If a request arrives in 0RTT, you know that the person sending it would have included this header. It's basically implicitly present by default. And that allows us to sort of not worry too much about annotating every single request that we ever send, and saves a little bit of space. The reject mechanism allows the server to force non-0RTT requests in the unsafe cases. That means if the server's unwilling to accept the risk of a replay, it can tell the client, hey, this is not cool, try again. There's a risk here again that if this processing is not consistent, you've created a side channel, so there's a little bit of advice about what to do in that circumstance as well. And the important point here that we had some discussion between the authors of the draft for quite some time is that the combination of these two mechanisms requires coordination between an intermediary who enables 0RTT and the servers that sit behind them. Because if these annotations are not understood by the servers in the back, then the servers in the back will not be able to reject things appropriately. And so the message arrives, it's marked with early data by the intermediary who supports this draft and implements it and deploys 0RTT, but the backend server doesn't even know to look at the early data header, and so it processes the message without knowledge of this risk that it has taken. And so that could be exploited in some fairly nasty ways. We don't really know any way to avoid this particular problem. I mean, once the request is being forwarded, then it's being forwarded. And there's some things we can do. But I think this is probably the best solution with that, without making the request completely incomprehensible. So we could ROT 13 the entire request if they came in early data and put the early data header field up front, I suppose. That would be we could do some serious damage to the protocol if we wanted to make this mandatory, but I think this is a reasonable compromise. So is that all I have? No, I have more.
Just a small clarification, which I think follows from what you just said. This isn't really for all intermediaries, it's just for gateways.
Yeah,
not for
so
forward
we
proxies.
specifically use the word gateway and the term there because I don't see this being useful in the forward proxy case, because the forward proxy enables
it's client configured.
The client connects with 0RTT, sends a request to the forward proxy, like you're going to do that anyway, but sends the forward proxy, and the forward proxy annotates in this way, but it's got no idea that the servers are going to be able to accept this understand the new header field.
And I think if I remember, there's still advice in there that if you're configured to use a proxy, you don't use 0RTT, correct?
Oh, you can use 0RTT because you're going to connect.
Yeah.
Right. So
sure.
it's,
that's right. That's right.
You can do whatever you want. Yeah.
Right.
I don't think anyone uses forward proxies without this. Oh yeah. So 4XX is one of our. We have this design pattern that we've started to use a lot more often, which is an explicit permission to retry something. It improves reliability no end. Importantly here, it's an automatic retry. and no matter what the request is. This means that clients can be more confident in attempting zero RTT because any server that accepts zero RTT will understand this, will reject something if the server believes it's safe. So if the client thinks it's safe, then they can attempt zero RTT. There was a risk without these mechanisms that the clients would not do this because of they don't know that the server's able to understand this, particularly in those intermediate-aided cases where you have the CDNs involved, or the reverse proxy, the gateways. And so it becomes a mutual thing. Both sides have to agree that it's safe to do this in early data before anything happens. Next example. So you can see in the example, you make the zero RTT request. It gets annotated by the gateway with the new header field. The server goes, hey, not for me right now, and sends back a too early status code. And then the client waits for the handshake to complete, then retries the request. Pretty straightforward. That's all I have.
Okay. Victor is waiting very patiently.
A question. So one thing which kind of feels weird about this design is that we don't actually have a standardized mechanism to communicate between gateway and server whether the connection was secure or not, as far as I'm aware. So early data feels a little bit weird in this context because it's like when you don't have early data, you don't know whether it was actually secure or not.
So Victor, in this scenario, typically the origin server is usually pretty well aware of the fact that they've employed a CDN or have a load balancer sitting in front of them. I'm not sure whether why you have this specific concern as a result of this. I mean, is it just an observation?
It's mostly an observation that just feels weird.
Wow. Another thing to feel weird. Yeah. Welcome to HTTP.
Especially with CDNs.
Subodh
Iyengar. So if I'm understanding this correctly, the clients don't send the early header, but this is meant for only intermediates.
It's implicit in the case when you put something in early data. The purpose of it is to signal that something on a previous hop happened.
So as a browser, for example, as a browser, if I'm sending a request over early data, then is it valid for me to actually include this early data header? Because that would be really useful, since without that, it implies that whatever the intermediate proxy has to have a separate API to receive early data to know that this data came over early data, because it's a single stream, like you've said in the document.
So there's a number of reasons, aside from the ones I mentioned, and one of the more important reasons is that it is often very difficult when you're constructing a message and putting it on the wire, knowing what the status of the wire is when the message hits the wire. And so this way allows the clients to send the same message twice and avoids accidentally annotating things that are after the handshake as being in this category.
Yeah, I think the same argument can be made about like receiving data as well, and some data as between the zero RTT and stuff. So I've assumed that like a reasonable thing would be if I have at least some data on this request serialized over zero RTT, I would include this early data header, and that would help terminating proxies not need to have the separate API for receiving zero RTT data. If they want to do something more fancy, they can.
You don't need a separate API. And the draft sort of explains this, that the terms under which we mark things is the handshake complete. That is the marker that we're looking for. Fair. And it's a very simple marker to get, and every stack that I'm aware of has a very clear delineation. You have a point in time at which the handshake is considered complete, and a point where you may be uncertain, but it's...
I'm going to cut in.
Fair enough.
We've got 20 minutes left and other things to discuss. Yeah. The focus here should be on whether there's interest in adopting the document, not on the deep details, please.
Okay. Yep. Good point.
Kazuho, as a server developer who has already shipped a gateway that supports zero RTT, I would love to have this document formalized early. And even before working group adoption, I'd love to have that 4xx codes specified as a specific number so that we can implement it.
We had some debate about what the number was.
That's a rat hole.
Be a teapot. Nick.
Yeah, Nick Sullivan. I like this. I support this draft. I think it's really good. The only question I had was how are you going to deal with interactions with TLS intercepting proxies?
It's the wild, wild west out there, man. Nothing I can do about it.
This is DKG. So the decision on the server side of when to send the 4xx is, I think, the least understood part of this. At least it's a part of this that I understand the least.
Yes.
I think the semantics that we want for that are you as a server must know the complete architecture of your entire operation, and you must be able to identify as an origin server the set of requests that are not permissible to be sent in a that would be damaging if they were replayed. And so when it said, you're effectively saying sort of permission to retry, what you're actually saying is there's no way that if this thing was replayed somewhere else, right? We're not saying, it's tempting to read this as the semantics are, okay, I received this, but for whatever reason, I'm not going to handle it. Therefore, it's safe to go ahead and retry, which is distinct from saying the request that you sent is not something that should have been in 0RTT in the first place. You see what I'm saying? Yep. What we don't want to do is we don't want the origin server to be like, okay, I received this, I'm not going to process it because it could have been replayed. Therefore, it's okay to go ahead and retry. There's two slightly different meanings there.
Yeah.
And it would be really bad if we gave origin servers the wrong guidance.
Yeah. And so this is actually the critical guidance, and that's the part that I'm not confident in.
So DKG,
we're close.
Is that something that you think would stop us adopting it, or something that we could discuss and perhaps?
No,
fix?
I think it's something that if I think adopting it is reasonable.
Okay.
I see the need. If we're going to have 0RTT, I see the need for this.
Okay.
But yeah.
Okay. So full disclosure. So along with Martin and Willie, I'm a co-author on the document. So determining consensus for this lies in Patrick's capable hands.
So we're going to seek consensus from the working group, do a couple hums on whether or not we're interested in adoption of this document. I guess first, can you hum if you have read this document? Okay. If you favor the working group, oh, we got one on Jabber there. Got to do both. If you favor the working group adopting the document that's been presented here, would you hum now? And if you oppose the working group adopting the document we've discussed here, hum now. Okay, that sounds like strong consensus, perhaps unanimity. Let us reflect at least 3 or 4 adopting hums on Jabber 5. They keep growing. So thank you, Martin. Thank you, Mark. I think we should backtrack and do origin.
Martin, is the person who you were concerned about now with us? I thought that might be the case.
I think we should give that priority because that's active work, right?
Yes, indeed. So let's talk about origin. Do I need to update?
Upload slides to GitHub.
Bugger. My glasses are now authenticated. There we go. I just need to pull it. It'll be a second. You go ahead and get up there.
Sure. They're more chair slides than personal slides. So is there anything to discuss on origin other than the active discussion on the mailing list as one of the authors? I do not believe that primarily there is some discussion that has been going on regarding a few things that Lucas brought up, and if you want, Mike, time to address those, I think that's fine. But the primary issue in the document has been this clause, and other than that, we are, I think, fairly close to wrapping up the origin frame extension. So the clause reads, clients must not consult the DNS to establish the connections authority for new requests. This is in reference, obviously, to origins that were in the origin frame, and it, of course, also involves the normal certificate checks from 7540 that are referenced elsewhere in the text. This clause, has clearly not yet reached working group consensus. There are a couple different schools of thought on this. So if you want to move to the next slide. I think there is consensus that the existing DNS provision in 7540 is a weak second factor involved in, establishing a connection. There is, however, disagreement in the group about, just how valuable of a factor that is. And so the discussion has been leading the chairs to ask, this question, is the substitution of a different, more performance and privacy-friendly second factor or factors, into the origin extension, a path forward. With that, if Mark, would you like to make any comments as, co-author of that? Document, not that slide.
So, I mean, from my perspective, I'm just looking, as an editor, I'm an editor on that document as well, for a way forward on it. And as I commented on List in the last day or two, historically, we haven't specified the exact stack of specifications that you use when you're validating a certificate for HTTP. That has resided elsewhere. The IETF defines a selection of those mechanisms, but we don't say in HTTP itself, you must do this, 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 or this. And so it seems like we should think about that before we go and specify specific mechanisms here. But from what I've seen, there does seem to be support for saying in a slightly more vague fashion, you need some sort of second factor beyond just the certificate itself. And it could be that mechanisms that we typically use to validate those certificates could also be used as that second factor to have more confidence in it. But I'm still looking as an editor for input from the working group on exactly how we want to go about doing that.
Mm-hmm. Comments from the floor?
Yeah. So Martin Thompson, I think this falls kind of into the territory of what does a client do to decide that a given server is acceptable for a given name? Yeah. And there is some commonality there, but there's also quite a bit of wiggle room. Our certificate transparency policies are diverse, and the way that we validate certificates is, in some cases, a little bit different. And we have different trust anchors in some cases. And so the idea that we mandate a single thing is, I think, the point on which we've actually sort of gotten wrapped around the axle in this discussion. And I suspect that the right advice here is that we acknowledge the possibility that DNS is important and that we're potentially taking that away. Recognize that the privacy benefits of doing so are significant, and then say that a client or user agent can make its own decisions about what policy it wants to apply in determining whether or not a given request can be made to this particular server. And I think that it's kind of weaseling in a sense, because we're just sort of punting the can down the road a little bit. But with a lot of these things, I think the normalization comes with time as we get more experience with the policies. I do think that there is value in having the must not DNS statement in here and retaining that, because I don't want servers to be in a position where they can't rely on this mechanism for particular properties, and that property that I care about here is not making additional DNS queries. And certainly in the current environment, making those DNS queries exposes certain information to others that I would rather not have exposed.
So just to respond to that, I get a little uncomfortable when you talk about servers relying on that property, because that's not a designed property that we have. And it's possible for, in error handling, in transient conditions, for a connection to close or for an origin to be popped onto a new connection, and all of a sudden it is exposed to the network. And if you're counting on it not being exposed to the network, that it seems like it's a much higher bar than we've currently designed it for.
It is.
You'd probably also need some kind of an acknowledgement.
Yep.
Eric.
Right. So what happens when you send this origin frame to an existing client?
Nothing.
Right. So it's already the case that you cannot rely on this property.
Right.
And similarly, any client which decided it didn't like the origin frame would then be emitting these DNS requests. So as far as I can tell, regrettably, regrettably, this is a best effort kind of situation unless we're going to create unless we're going to create some indication from the client that says, I promise to speak origin and I promise not to do DNS requests in those circumstances.
Right.
But
that
would be a new kind of interlock that we have not previously done.
But we could put in an acknowledgement, like, essentially.
Yeah. We could put a thing where the client said, and right, you would think where the client could say that those are my semantics. It's not entirely. I guess the question then becomes is how would we actually expect the server to behave differently under those circumstances, given that presumably the situation at hand is the client is going to attempt to dereference those URLs, and if the client refuses to accept the server's not going to send you some content which causes external linking because you said screw you, I don't like origin. So I guess I don't understand. I certainly agree it's a desirable property to conceal the DNS requests. I just don't understand how is the server going to depend on that property, even if it could?
Yeah. So I agree that this is DKG. I also don't see how without some additional mechanism, and I'm not even sure what the mechanism would be, that we can make this a must, although I agree that it would be nice to make it a must. This statement of the problem that's on the screen right here, I think is problematic because it says existing DNS provision. What it's really talking about is existing DNS over the local network provision. There are multiple ways to get DNS data. And I think if we're going to frame the problem like this, we should be clear that we're talking about the network path being the additional weak second factor, not the fact of DNS data, period. So for example, I could have some additional out-of-band channel that gives me DNS information, or I could have an in-band channel that gives me DNS information, not to bring this working group to the question of dope, but it's not about DNS data, it's about what came over the local network.
Well, the provision of 7540 is about DNS data.
Ecker, we've got some remote people waiting. Let's do one or two of those, and then we'll get.
Oh, sure, of course.
Piotr Sikora, Google.
Sorry, we're
on mics.
On remote people. Yes. Go, Mike.
Hey, so I'm going to echo the concern that I don't really want to see this as a must not, because you have existing clients that already have coalescing logic, and I don't think that this should depart from that substantially. If we want to say that it's a client's may do other things, may omit the check, and have some guidance as to what you might look for before you make that decision, I think that's probably a smarter path. I also will repeat what I said in the Jabber, that we're also later today doing an adoption call for a draft that says the exact opposite. The clients must still do DNS. So we need to reconcile this one way or the other in both drafts.
Multiple documents in play.
Thanks, Mike. Go ahead, Ecker.
Oh, yeah. So I guess two things. First is that I think DKG is partially right. The weak second factor is the ability on the network path that is allegedly associated with the DNS. And that would be a weak second factor even if the DNS were entirely trustworthy. Namely, say you got that over DNSSEC, like the issue is the fact that the attackers always control the network between you and the website, right? So what the DNS is attempting to give you is, even if we trusted the DNS entirely, is not being routed to some entirely third location, which is not associated with the origin that you care about. The second thing I was going to note is that we actually can take three postures. One posture is the one that's in this draft, which I think nobody likes very much. The other is to sort of kind of encourage people to do some other second factor and not say what that really is, but say there ought to be one. And the third is to say we take no position or are hostile to the idea of a second factor, though we suppose you can. So I think, this is sort of a very Weasley kind of text. I think it might be better simply to document exactly what the assumptions are and say, we leave it up to the implementations to decide how to behave. I don't know. Like,
so not place requirements around them, just document possibilities.
yeah, I mean, my sense was that that many of the people on the mailing list resisted the idea you should not do a second check, and so if we're going to say, so that means saying don't do a second check to be problematic. But on the other hand, I sense there are people, I sense there are people on the discussion who thought a second check was silly, and then I'm like, that makes me not very enthusiastic about recommending a second check, especially when there appear to be 8 different second checks with extremely different security properties.
Right. Okay. Victor.
So if there is one thing which my experience with browsers and socket pools has taught me is that normally they cannot promise you that they will handle requests in certain way. They will try to handle it optimal way, but God knows how it will be actually handled. So I do not believe that from perspective of user agent, this is actually a viable strategy. The assumption of not having DNS queries is viable. So I side with Acker that we should document that there might be a second factor required by user agent, and document clearly what happens when the user agent declines that second factor, and whether it declines it explicitly or implicitly, but leaves the specific policy up to browsers.
Thanks, Victor.
Piotr Sikora, Google. So I would rather see us decide what should be the second factor, especially since some of the considered options would require changes to the format of origin frame. For example, if you want to staple DNSSEC response and send it inside origin frame, that's part of the draft, and it cannot be like hand wave it and say like clients do whatever.
Ben Schwartz, I agree with that. It does seem like having even just a relatively open-ended extension field in origin to be able to figure this out later would be nice.
Last word, Martin.
Let's hear from Eric.
Oh.
Audio working here?
Yes.
Yeah, I think one of the things that worries me is trying to, while I appreciate the desire to have kind of do some of this for privacy reasons, trying to have something that's not explicitly designed for privacy is just kind of a piece of an overall privacy story seems like it could do more harm than good. And it may make sense to take the design of a privacy-specific thing and look at what are all the pieces needed together and treat that as a separate draft, and have the origin frame itself just go back to not changing the existing behavior. Because prior to origin frame, there already are constraints on what sort of coalescing is needed and that are allowed, and that DNS needs to be checked. So the most conservative thing to do would be for origin frame to not relax that requirement, and then for us to look back separately at building a better, kind of more comprehensive story on how we might want to relax the DNS requirements in a way that does or could build up a comprehensive privacy story.
So Martin Thompson, I just wanted to push back against the suggestion that we hold this one because we might want to make some changes to the origin frame. I think if we do want to make if we do want to say do some DNSSEC record pinning, then we would find a way to do that virtually orthogonal to all of this. And I just keep coming back to the notion that this is really kind of this DNS requirement is really a policy decision that we made by accident, I think, more than anything else. And that we're relying on it so thoroughly it's kind of sad, but we kind of it's like one of those ossification things. We ended up here by accident, and now we find that we can't remove it. And I don't know it just makes me sad that that's where we're at. I would rather leave this completely for the time being and learn some things maybe before we actually commit to something.
Okay.
So I think the chairs will have to huddle and sort of reread the minutes here. But thank you all for the comments. AD Adam Roach, are you still in the room? All right. Okay. Well, based on that, we're going to do the discussion of BCP 56-BIS next. And hopefully we'll talk about HTTP chur as time allows in our next session. We'll try and carve out a little space for that. But we appreciate Adam making time to be here for this.
Okay. If I can get to it. All right. So this is another proposal for a document that I've been working on in the background for a little while called BCP 56-BIS. And the original BCP 56 was on the use of HTTP as a substrate. So basically, how do we use HTTP well when we use it with other protocols that are defined inside the IETF? And it was done, this is from the data tracker, as you can see, in 2000 to 2002. It had just a couple of drafts from Keith Moore and was published way back then. And this is the abstract, which I find the recently somewhat amusing. It turns out we now have a lot of interest, and quite widespread interest, in using HTTP as a substrate for other application level protocols. I have a cron job on one of my boxes that emails me and Patrick every couple of weeks now and lists all of the IETF documents in working groups that reference HTTP. And this is the current run of that tool. There are lots of people, using HTTP in different ways, and this doesn't actually list them all. There are new working groups spooling up all the time that's saying, oh yeah, we'll use HTTP for that. And I don't have time to review them all and give them advice. Julian, I'm sure, doesn't have time to review all the header fields that they create. He is our bottleneck for header field syntax, as well as other things, of course. There's a lot going on. We're seeing an explosion of this, not just in the outer world, but in the IETF specifically. And in the outer world, it's happening as well. HTTP APIs are used for everything, including cat GIFs. And the problem that I see, or maybe problem's too strong, but one of the issues is that people design an API for their own server to deploy to serve cat GIFs via an API, and they don't think about the implications of taking that API designed for one HTTP server and scaling it out to multiple HTTP servers, multiple implementations with different versions and different extensions, and the coordination problem that entails. It requires a different kind of protocol. But they're still using the techniques that they've learned deploying their single implementation and deployment API. On the other hand, it's very easy for an effort to give this kind of guidance to turn into a bit of a crusade, to say thou shalt be restful. And I really want to avoid that minefield. I want to have advice that is useful to people based upon the experience we have as a community for using HTTP as a substrate. And so that is the line I'm trying to walk, and it's very embryonic right now. That's the line I'm trying to walk in this document. It's very bare bones right now, but I think the question I have for the working group as an editor of that document is, are we interested in starting work up in this area again? The hallway chats I've had personally are that people recognize it's way past overdue for revising this advice, because the world has moved on considerably since 2000 and 2001 in terms of how we use HTTP. And so I wanted some feedback as to whether people are interested in working on this and giving feedback. I've already had a lot of feedback during this meeting that I've started to incorporate in the document. There's certainly a lot more work to do, but I'm very interested in doing this, if only to save us the time and the effort of scaling out to individual reviews all the time. Jana
Iyengar. I think, I think that it makes complete sense to consider the things that you would need to do to make HTTP a good substrate, if that's part of the goal of such a BIS document. And I think it's absolutely appropriate. In particular, when something becomes a substrate, which HTTP has, it ends up baking things into it, which people don't realize that don't scale widely to large numbers of applications. Latency is one of those things. When there's a tiny bit of latency that's baked into the substrate, things that build on top of it end up having deeper and deeper latencies, and that's not a good thing to have. So being able to document all of that stuff is very useful. At the same time, I wonder if this is the community that would be in a position to do that. What I mean by that is the people who are actually using HTTP as a substrate are likely to be folks who don't care about exactly what is going on underneath, but are more likely to simply grab a library which they can use to talk easily to the other side and use the surface of it and use HTTP without necessarily caring about exactly what's going on underneath.
I think that's true for folks outside the IETF, but we still have folks come here who want to use HTTP as the protocol. And JMAP is an excellent example of that. We spent some time with JMAP this week talking about their use of the protocol. And for me, that was an exciting thing to do because we learned that they had requirements that we weren't meeting. And so now we can start to think about how we could possibly meet those requirements. And also we can give them, at the same time, we can give them some guidance of where they are able to use existing things in HTTP. We can guide them to make sure that they're not breaking other stuff or that they're using it well. So I think, certainly there are folks in this working group who this may be too high a layer for, or too semantic for, but there are also a lot of people in this working group, I believe, who have a lot to say about this and have the right experience to do it.
Yeah, I should probably change what I said. You're right, of course. And I guess I was thinking that there are people who are not in the room who you may want to invite into the room to talk about how it's being used. Sure. That's perhaps a slightly different point than what I made earlier. Is part of the goal also to document issues that are I mean, this is going to be a BCP.
I don't know that they'd appear in the document, but certainly if we encounter things that, are too gnarly to put in there, I would like to resolve them somehow. Yes.
We'll cut the line after Adam.
Separate document, whatever.
Yeah, Martin Thompson, I like the general goals and particularly the way that you stated them. I'm going to push back a bit against what Jana said here. One of the core things that I think this document kind of needs to say, if not directly, but sort of at least cover, is that HTTP is not a dumb transport protocol.
Right.
It's an application protocol, and the consequences of that are what the document explores in great depth, and that's valuable. To the extent that HTTP serves the needs of people, we should make it better suit those needs. But I'm not interested in having the discussion about how you might use it for a multiplexing protocol or as a substrate for tunneling various other things over the top. I think that's it's one of the ways in which it has been abused, and I think we can talk about things like event source and various other things where they basically treat it as a transport protocol,
right?
And it is kind of ill-suited to that.
I will just add to that, Jana, every time you call HTTP a transport protocol, Roy Fielding knows, and he will find you. So. It's transfer in the name.
It's not.
Adam Roach, I wanted to stand up here mostly because while the example of JMAP is interesting, they're kind of, a motorcycle with, a relatively small crowd following behind it. We have a freight train called 5G that has already said that they're looking at HTTP for their, working between their services. They're basically breaking their monolithic services down into what looked to me like microservices. And they've already strongly signaled that they're likely to want some changes here, right? So we should definitely have some guidance in place for them before that happens. But I think that's probably a lot more motivating than the current ongoing efforts inside the IETF.
Alexei.
Alexei, as an area director, I review lots of documents that try to use HTTP.
Sorry, I can't quite understand you.
As an area director, I review quite a lot of documents that try to use HTTP. So having a single point where, partially as a checklist, partially where to send people, go fix these things, would be very useful for me. So.
Okay. Thank you. And to be clear,
yes, I'm very excited if you can actually do this job.
Right. I I'm not at all attached to the current form of the document.
John.
I think it probably needs to change quite a bit. So
we're
out of time.
We cut the line, John. Sorry. And we are out of time in the session. So we will.
Do you want to ask?
Would you like this adopted? Just interested in working on it?
Maybe not quite yet. I probably want to do another revision before we adopt. Okay. Never mind.
I think. Yeah. I think we got a sense.
Yeah.
All right. Thank you, everyone. We'll see you back here, hopefully at 3:20 for mostly quick and HTTP, but if we can, we're going to sneak in HTTP TER if we got time as well.
And Julian called it Trey in his slides. It's TER. I looked it up. It does. It does.
It's just like an alternative.
True.
So it's fine.
This prime. I like this.
Hello. I was going to ask, which we didn't have time for, is do you intend to cover HTTP as well as 1.0?
Yes, I do. It's not in there yet, but I do.
What Adam said, I believe that most of